Struggle with the substitute.
Okay, here we go. Oh, these are so cute. I just taught the baby ones. I think I told you to my math one class, and they're just starting to. Oh, it's adorable. Anyway, okay. So, what is the common base I should use in number one? 5. Beautiful. 5, 3p minus 3 equals 5 squared. This is about where they're at right now. Cancel the 5s. 3p minus 3 equals 2. P equals 5/3. I'm not going to be freaked out by how weird that number is because I'm going to remember that Miss Rice and Miss Talbot do not want you to be able to guess and check them. So we're going to give you some kind of weird answer. Just jerks like that to make you actually have to do the problem. Okay. What, us being jerks? Or us not guessing and checking, or all of it, all of the above? Okay. Number 2, what base should I use here? And the answer is not 8. 4. 4. Okay, so over here, I'm going to say 64 equals 4 to the third. And 16 equals 4 squared. These are just my little references I'm going to use. No problem. So 4 to the third. And then the n gets multiplied on equals 1 over 4 squared to the 1 minus n. So my first step is to replace the 64 with 4 to the third and replace the 16 with 4 squared. Okay, now I'm going to move the 4 squared upstairs. And then you need to make sure that the binomial exponent is put in parentheses for a distributive property. Oh man. Yeah, was I a giant liar? I'm pretty sure I spoke too soon. hmm You could probably sit on the calculator, try to mess with that one, figure it out. Or, or just do the problem. Okay, now number 3 is gonna take us a minute. It's an inverse problem. But I am gonna do a little bit of cheating. And the reason we're gonna do a little bit of cheating is because your test is next Friday, but you know you get a graphing calculator. So I want to remind you how to do the table off of the graphing calculator. We're just gonna skip the mental math portion. Okay, so scroll on over to number 3. And I'm going to do everything for the original function in blue and the inverse in pink. I know that's shocking. Try not to have a heart attack over that information. But before I start, I want to ask you, what is the locator point for this cubic? 0, 2. And the reason it's 0 is because there's no parentheses. So that means it's x minus 0 in there. So the reason I'm saying that is because you should put that and then in the middle of your table and then get the rest of the points from your graphing calculator. Okay, so let's remind ourselves how to do this. Oh goodness, I'm logging up a storm on the calculator here. Okay, so hit the y equals button. negative 2 x to the third plus 2. Nope. I got an arrow out of the exponent. There we go. Remember to hit the negative and not the minus here in front. Okay, and then remember, tables up here above graph, and everything above the buttons, you have to hit second first. So second, graph, and then scroll until you find the points you want. So negative 1, 4. I'm clearly not going to be able to graph all of these. 0, 2, 1, 0, 2, negative 14. That's not going to happen. Negative 2, positive 18. That's also not going to happen. Does anyone know why my table's going from tiny to big? No idea. No idea. Just because I'm special. Okay, so negative 218, not going to graph. Negative 1, 4. 0, 2, 1, 0. Okay, and then what I like to do is I like to just hit the graph button so that I could sort of make sure that mine matches the way it looks. So I don't forget the flat bit for the inflection point. Okay, and then there's one more thing we need to do with the blue pen. That is find the steps. Okay, if I plug something in for x, does exponent go first or multiply? Exponent goes first. Then multiply. Then add 2. Okay, is that everything for the blue pen? I think so. Okay, we have one more thing to do. Steps and write the inverse. Okay. Minus 2. Divide by negative 2. Cube root. We start with an x. Minus 2. Divide by negative 2 on everything. Cube root everything. And then if you're feeling feisty on the test, if I were you, I would just put this guy into the Y2 and just make sure that it looks like it's supposed to look. Any questions from number 3? Okay, number 4, I'm gonna do the stacked function machine method. Remember, there's 3 different ways you could do this. You could do the inverse of one and see if it's the other one. You could graph them both and check to see if they reflect or if their tables are flips of each other. I like to do the stacked function machine method because I'm lazy. So what that means is I'm going to do g of 0. So I'm just going to pick a number. Again, you have to be careful with the domain. If there's like a square root or something, you have to make sure it wouldn't be like imaginary or something like that. But these are just lines. So -4 minus 4/5 times 0. Yep, equals -4. Okay, and so that means I'm going to plug -4 into the other one. And I got 0 back out, so they're inverses. Because if you think about it, like it's just a flip table, right? So 0, -4, and -4, 0. Okay, number 5 and 6, I'm going to use my blue sheets for the logs. Scroll down there when you're ready. Identify the domain and range of each, then sketch the graph. Okay. We're going to do more than we need to. I'm going to find the asymptote first. That's how I graph it though. So vertical asymptote at x equals h. What's h in number 5? -5. Okay, so I'm going to say vertical asymptote at x equals -5. And then I'm going to go to -5. Okay, next step for me is to find the locator point, which is h plus 1 comma k. Okay, h is -5. Yep. So -2. Whoa, that's not -2. -4, 3. Okay. Now, I'm not going to do a table for this. Again, you'll have a graphing calculator to use on your test, but you can just sketch it. This one has a positive A value, which means that it's going to come from the bottom and increase. Yep, so you make it go along the asymptote, and then the locator point's kind of like its launching point, like it launches it off to the side. And remember what I said, if you graph these on the graphing calculator, what's going to happen? Yep. Okay, now domain and range. Domain is x is greater than h. And range is all numbers. Done. Not really that bad. Okay, now notice I put 2 twists in number 6. Plot twists, number 6. Do you see my plot twists? Negative log and yeah. Okay. Now the 10 base really isn't going to affect you here, but just to get in the habit, I'm just going to put a little baby 10 there. We don't really, since we're just sketching, we don't really care about the base, but just want to remind you, base is 10 when there's nothing there. Why? Because you have 10 fingies. Okay. Vertical asymptote at x equals -2. Everybody good with that? Yes, okay. So h plus 1 comma k, -1, -5. Okay, now this one is a negative log. Yep, so it comes down the asymptote instead. And then decreasing. Domain x is greater than -2. Range all real numbers. Okay, flip your paper over when you're ready. All right. The assignment or the notes? Oh yeah, it's because these problems, all of these take like 3 seconds. Okay. Number 7. Find the inverse. So we're going to do this with steps. Okay, so plug a number in for x. The first thing that I would do would be log base 3. And then I would add 10. Everybody good with that? Okay. Undo the add 10 first. And then undo the log base 3 is 3 to the power. Y inverse equals. Okay, now start with x. So they might look stupid at first. I tell you guys to start with x every time. And the first thing you think is like -10. And then you're like, oh, 3 to the power. That looks kind of dumb. So you might want to rewrite it that after you do this. Now for me, because I've done this so many times, I can tell that if I 3 to the power, whatever's going to come before that's in the exponent. So I can plan ahead, but you guys are just learning it. So you might end up with an ugly one. Yeah, just rewrite it to make it look nice for your final answer. Okay. Number 8. Okay, plug in a number here. The first thing I would do would be 4 to the power of it. And then -3. plus 3 log base 4. Are we getting the hang of the powers and logs there? Okay. Y inverse equals, okay, I have a log for it, so I know I'm gonna have to leave some room. So start with the x plus 3 first, and then log base 4 of everything. Okay. Number 9 is a Guinan circle problem, but these, you're not going to solve them. You're just rewriting. Notice the directions, just say rewrite. I need to do Guinan circle, but I don't have a base, so it is 10. Guinan circle, 10 to the v equals u. That's it. The question is just asking you to rewrite. It's not asking you to solve. Guess where we're going to solve? Number 11 through 14. Okay, but these are just asking you, do you know how to rewrite? Okay, now log form. So I'm going to start with log. And I want you guys to remember that the base of the exponent is the base of the log. So the base of the exponent is the base of the log. Okay, the exponent is the answer. And then whatever it equals is in parentheses right there. If you don't like that, what you can just do is play with it until you Guinan circle your answer to get it back to look like that. So 4 to the negative 5 equals x. You see what I mean?
Yeah.
So you should be able to Guinan circle your answer back into the question and check to make sure you did it correctly. Okay. Equals x equals x equals x equals x. Three to the x equals 81. 81 is 3 to the 4th. Oh, my freshman did this one today. 6 to the x equals 36. 6 to the x equals 6 squared. They did not do the log problem. They just did 6 to the x equals 36. And they nailed it. Okay. 6 to the x equals 1 over 36. And I made these review notes on purpose so you could see the difference between these two problems. One of them just being 36 and one of them being 1 over 36. And again, I'm going to do it in 2 steps because I think it helps your brain. I'm going to change the 36 to be 1 over 6 squared. And then move it upstairs. Okay, now this one we got to slow down a tiny. 243 is 3 to the what? What, maybe? 240. You have a calculator, remember? 3 to the 5th, right? Okay. So remember, when you change that to 3 to the 5th, the x will get multiplied onto the exponent there. And then you have to remember that 3 to the 1 power is 3. Mhm. Yep. Okay, because the directions are going to say rewrite into exponential form and solve. They're not going to say plug it into your calculator and do log base 243 equals 3. Now, can you use that to check your answer? Absolutely. Okay, back to yeah, okay. So square root equation. First, you have to get the square root alone. So add p to both sides, and then it will look more normal anyway. Yep. And I would put the p in front just so it looks normal. You can put -8 plus p if you want to, but I just don't like the way that looks. Mm-hmm. Hold on. I'm gonna move everything over, get it equal to 0, and then factor. Yeah. You guys get the same thing as me? Those are weird to check because of the minus P. I don't know. It's in a weird spot. So I like rethought myself. The one on the left also negative too? No, Why? square roots are negative. But if you square a negative number, then. You don't square it because it's not an equation. It's just order of operation. Okay. So you're thinking of the difference between this and the difference between this. These are two very different things. This is just a number. This is an equation where you're solving for x that has two possibilities. I think that's what you're thinking. Okay. All right. Last one. Get ready to color. Yes. Okay. All right. First one, exponential. That's weird. Okay. But remember, we have a graphing calculator, so we're not on a quiz. We can cheat a little bit and get the table from here. That's not what I wanted. That's not what I wanted. Grab a few points from the graphing calculator table. Cheating just a little, just a tiny, just a smidge. Just efficiency for speed purposes. Second graph. Okay. Dashed or solid? Solid. Yeah. 0, 0 is okay to test, right? Excuse me. It is. You can clearly tell it's underneath. Mm-hmm. Okay, now for the parabola, I'm just going to graph the vertex and use the a=1 trick, except for that it's going downward. So the vertex is -3, 5, which is here. And a=-1, so I can use the a=1 trick going down. And this one's dashed. This side doesn't really look dashed on mine, but I meant it to be dashed. 0, 0, okay here? Mm-hmm. Dang, that's satisfying. Okay, when you guys are done, can you flip to the stamp sheet side, please? And thank you. Okay, so I have two more things I want to do. They're very quick. So this should be done and stamped. This should be done. This should be done. Your review assignment is the weekend and Wednesday night's homework, so it's due Thursday. We have a team test Wednesday, scavenger hunt Thursday, and I'll give you note cards out on Wednesday. Does that all make sense? Okay, now let's look at the test topics and make sure that you guys understand what the words mean. None of those things are the things I wanted to show you. Okay. Okay. Test is on Friday, a week from today. You can use the front and the back of a notebook. And a copy. How it's said. Okay, for two multiple choice questions. Sketching a transformed logarithm graph. So review notes, that was like the two at the bottom of the first page where you have the vertical asymptote, locator point, sketch. If it's negative, it comes down from the top. If it's positive, it comes up from the bottom. Does that make sense? So you're gonna want your blue sheet page for the logs for that. Okay. Rewriting a log into exponential and evaluating. That's Guinan circle and then changes it into a same base exponential for x. You guys know what that is? No. Okay. Writing the inverse of an exponential or logarithm. So that's doing the steps, doing the inverse steps. And when you do like a to the power, the inverse will be the log. Or if you have a log, the inverse will be to a power. Okay. Solving a square root equation and checking for extraneous solutions. If you know what that just did one. It was large. An inch up. Okay. Graphing a system of nonlinear inequalities. That's what we just did with the testing and shading and double shaded region dealio. This can be anything from your blue sheets. And what I mean by that is any shapes that we give you from the blue sheets. So if you have an old note card with your blue sheet stuff still on it, you could like say staple it to a new note card and then just fill out the other side. That would be just a hot level of cheating right there. Ooh, yeah, just as long as it's stapled, so you know. Yeah, so you can't use, four sides. In the middle of the test, you're like, okay, and then writing the inverse of a function, sketching the graph of the original and its inverse. So steps, table, flip the table, sketch the two, y equals x symmetry. You know all that stuff. All right, so you have the rest of the period to work on your review assignment. Yes, yes, yes. Yeah, you guys, gotta figure out your bladder situation someday. Be great. You could do that. Be awesome. What? I am.
You already know what I'm gonna ask.
Bladder.
Can I go to, oh, my no.
Sure, but take the path. Your other two classmates were dumb and did not dumb. That's not the word. They were, they were unobservant and didn't take the path. Oh, I got it. I got it earlier. I got it. I got it. I saw it come through. I was excited. Thank you, honey.
Bring your water.
Yes. Tony, will you send me Nathan's quiz? I should take a $10.
Are you checking?
I wasn't, but I can check whatever.
Okay.
For your, stamp satisfaction purposes.
Yes.
Cody, how's the, tryout situation?
I made it. I made it. I made debut, but not varsity.
That's normal.
But they said that I could get pulled up.
Okay, but you're a sophomore, so Davey's normal. You shouldn't be sad, I'm saying.
It's all right. Next
I'm
year.
proud of you.
Thank you. Thank you.